Lab 3 involving the black hole. So the objectives and results. So the purpose of this lab was to find the mass of a black hole using GlowScript. And then using this mass that we find, you can find the initial velocity of a spaceship, what it would need to have in order to orbit the black hole without crashing or getting sucked into it. And I found the mass to be the black hole 7.2 times 10 to the 33 kilograms. And this was the initial velocity I found in the X and Y direction. So these are important physics concepts and equations. So you have Newton's second law, which is F net equals ma, and then you have F net in the perpendicular and the parallel direction. You have the universal gravitational force, which is negative g, big M, little m over r squared times r hat. And then you have the velocity update and the position update formulas, all of which we will be using in our code. So some things to consider for part 1. So we're in space, so the only forces acting on the star are the gravity of the black hole. The system is the black hole and the surroundings are star. The mass of the star is 2 times 10 to the 30th kilograms. G is 6.7 times 10 to the negative 11th, and the time interval we're using for this part of the code is 1 Earth day in seconds, which came out to be 86,400. Okay, so part 1. In green, you can see that we have the net force, and then in blue, we have the parallel components. Purple, we have the perpendicular components, like we were talking about the F net, parallel, and perpendicular. And then the orange is the formula we're using to find the mass of the black hole, so you can plug everything that you know into that specific formula. And so the mass that was generated ended up being 7.2 times 10 to the 33 kilograms. So in the F net direction, you have 8.03 times 10 to the 28, and then the F net parallel, this is magnitude by the way, it was 1.09 times 10 to the 28, and then for the perpendicular direction, it was 7.96 times 10 to the 28. And then that is the model in the corner, as you can see. So now we're in part 2. We have different systems and surroundings. The system is going to be the spaceship. The surroundings would be the planet and the black hole. By the way, in this thing, the velocity was guess and check. So as you can see at the top, you just plug in the black hole mass that you got from the previous part. All of the conditions are there, so such as G being 6.7 times 10 to the negative 11th. I made my T max to be roughly in the 3 hours, so that it could have enough time to fully orbit. And then I did guess and check for my speeds. I said in the X direction was -6, and then Y was 0.22. And this ended up helping me to get a full orbit, considering my mass. All right, so we have, in green, we have a bunch of things that you have to type into the code, like the R for the planet and the ship. You have F net on the ship. Down below, you have the velocity update formula and the position update formula for both the planet and the ship. These are important things that you need to have in the code so that you can get a proper orbit. And my image is really small. I don't know why that is, but as you can see that it did orbit fully and it left. And so I got pretty close. The ship is 2.84 times 10 to the 11th meters away from the horizon of the black hole. So it was pretty close and the conditions were met. Okay, so some sources of error in this experiment. So the mass was an average from part 1 of the mass of the black hole, so it's not completely accurate. We were given lots of masses that we had to take the average of. My programs could have been run longer, specifically for part 1. Part 2, it was pretty good with time, but part 1 definitely could have been run longer. And obviously the initial velocity for part 2 was a guess. I did not mathematically solve for it at all. I just typed in numbers until I got the conditions that I needed. So not the most accurate. All right, what does it mean? So it's basically asking, like, discuss the net force and its parallel and perpendicular components, how they're different from the rate of change of momentum and its parallel and perpendicular components. And so I said for F net, you need to know the mass of the black hole, but with the rate of change of momentum, you can solve for this mass with the star's position, velocity, and momentum because they change over time. So basically F net perpendicular and F net parallel can be observed easily. However, the magnitude is harder to find, so basically the rate of change of momentum is easier to observe. All right, what if? What if you wanted to take a quick look at the black hole and leave? You decide you want to enter an orbit around the black hole. What initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? So basically, the x component velocity should be very low, below 1. Basically, that's what we observed in part 2. As you can see, my velocity was negative. It should be less than 1. And like I said, that was used in part 2. And then the y component of velocity should be a lot bigger. Once again, that could be observed in my initial components for part 2. My y component was a lot bigger than my x component. So thank you guys.